Hi guys, welcome back to another video. In this video, we are going to talk about or walk through a real-world GCP architecture that we typically design for our enterprise environment, especially for a banking infrastructure. So this includes how we design a VPC, uh, your identity and access management, Kubernetes workload for GKE and Cloud Run, and multi-region high availability and security best practices. We will be talking about all these things on this video. This is a real project experience based training for a large scale infrastructure. Now, let's first talk about the architecture here. So we are having a region. The internet is coming through this, and you have the cloud load balancer over here, and then you have the shared VPC. Now, first thing to understand about the architecture is about the shared VPC or the VPC design. So you have two types of VPC design. One is shared VPC and standalone virtual private cloud. So in an enterprise setup, we typically use a shared VPC. This means that uh, a, a central host project where the network is defined and multiple service projects can consume this network. So why do we use shared VPC? Because it gives us centralized control over networking, security, and IP management. It also enforces governance across teams. We usually define subnets based on environment. Now, subnet is where the fine-grained configuration of network comes into picture. Though we use shared VPC based on the subnet like subnet dev, subnet UAT, subnet prod. So we have created multiple subnets over here. Each environment is isolated using subnets, and within that you have firewall rules and access controls. So this is a smaller setup what I've just given you, and the standalone VPC can also be used in banking environments, and shared VPC is basically a standardized practice of using it rather than standalone VPC. VPCs are basically charged. We will talk about how it is charged, how the calculation is made. We will talk about that later in detail. But let's just go proceed with this architecture. We will come to this workload little later, but let's just finish IAM over here. So we follow a least privilege model. So that's what is recommended on any banking infrastructure. Instead of assigning permissions directly to the user, we assign roles to groups and users to those groups which we have created. So we also separate access based on environments, like for example developers gets access to development environments, or where we are segregated using subnet dev, and limited access to production and admin roles are tightly controlled. So these are some of the access based environment segregation. So service accounts, on the other hand, are used for applications, and each service which you have has its own identity. So service accounts is for service, and IAM roles is for users who gets access to the groups, and then groups in terms has the roles assigned to it. So service account, it's isolated for services which wants to use a certain service on your GCP. This helps in auditing, security, and compliance to segregate them to give a least privilege model. Now let's quickly talk about the workload over here. Now workload currently is containerized over here. So in most of the situations, if you're not using legacy applications, we're using microservices and things like that, we would be containerizing those applications using GKE. GKE is the answer for Kubernetes environment for Google. So GK is used for long-running services, microservice architectures, stateful or complex workloads. For lightweight or event-driven workloads, we use Cloud Run over here. So that's another option. So the arrow mark is going from cluster to Cloud Run. So sometimes there will be a connectivity from GKE cluster to Cloud Run, or sometimes they run independent from each other. So Cloud Run is ideal for APIs, background jobs, event-based processings. So typically, a core application runs on GKE and serverless mode runs on Cloud Run. Sometimes they are interconnected, sometimes they are independent from one another. These combination helps cut cost or optimize cost on your infrastructure, and also provides you scalability as part of this. So again, the fees or the price you need to pay for while running these services, we will discuss that on a later session, where we understand which is cheaper in which scenario, which is expensive. So all those things we will discuss later on probably further down the line. And let's talk about multiple regions here before we go to the security layer. So regions helps you to have high availability on a critical banking system. Let's say, for example, we have designed this application across multiple regions. So here I've given an example of region 1 and region 2 over here. I just replicated the same diagram. I duplicated the diagram because there's not much change on the diagram itself, but then it is populated on region 1 and region 2. Now, how this is going to help? Let's just say, for example, you have hosted one primary region as Europe West 2 and a secondary region as Europe West 1. So what this going to mean is that all your clusters, all your cloud runs will be available on both these regions, which means a war is declared on a specific region, that wouldn't affect the performance, and it will go to a different region on the Europe West 2. So even if a data center goes into a disaster, that will also be handled because you have a secondary region on a different location. So this is not just high availability in terms of servers, but also in terms of data centers and in terms of different regions as well. And you can also put in regions like not just in Europe, but also in the US or in the Asia as well, to to have a diverse region connectivity. But do remember, the more farther away you're going to go from your customers, the slower it's going to get. So you have to see where your customers are from and then host these on appropriate regions. More information on the regions and where these regions are, how many availability zones or the data centers you have under a region. We will talk about that later. And you can also refer the GCP guide on the internet to understand more about that as well. Now, traffic is routed through a load balancer, as you can see over here on this picture. We call it the cloud load balancer. So this we also implement health checks, failover mechanisms, data replications. This is to ensure that if one region goes down, the system continues to operate irrespective on from the other region. Now, in terms of security layer, security is implemented at multiple layers over here. So I've just given you a simple 3-point security layer over here, but it happens on different layers. Now, network security we talk about is firewall, private cluster, no public IP address for workloads. So these are some of the securities. Some say like it's not like defined as a security role, but then indirectly it's related to security. For example, no public IP address on workloads. So that is not actually has any word on security, but then it in turn talks about security itself. And then we have we can use the identity level security like IAM role, service account, workload identity, likewise. So this is comes into authentication and authorization kind of security. And then in terms of data level security, we have REST, encryption at rest, and encryption and transit. So which means that the data which is resting on your infrastructure in GCP, so that needs to be encrypted, as well as the data which is getting transmitted from one place to another should also be secured. So these are the security implementation which we will be talking about. Please forgive my typo over there. It's encryption there. So it's a basically what I was just talking about just now. You have secret manager as well to store secrets like passwords, key files, and stuff like that. So that those are also encrypted. So that also comes in the encryption at rest. So these are data which is stored on the server. So that comes under encryption at rest. So pretty much the security layer is how we have designed, but then there is a larger or a very different architecture for that as well to work with all different types of securities which we have. So on an overall scale, so this is how the architecture or high level view of an enterprise GCP architecture is designed. This approach ensures that the scalability, security and reliability is maintained at all time. If you are preparing for an architecture or read role, these are some of the very important patterns you need to notice. Thank you for watching this video. I'll see you on the next one.